Bismillahirrahmanirrahim. Assalamu alaikum. Good morning, students. I welcome you all to Nasra Public School online teaching system. Week 3rd, subject computer, class 8, chapter number 1, more on number system. This is the second part of this chapter. Before starting this lecture, let's discuss the students' learning outcomes. By the end of this lecture, students will be able to convert decimal numbers into octal numbers and decimal numbers into hexadecimal numbers. Does anyone remember the base of decimal number? It's 10. Now let's take a quick review of what we have learned in our previous lecture. As we have discussed number systems. Number systems are the techniques to represent numbers in computer system architecture. There are 4 types of number system: binary, decimal, octal, and hexadecimal. These numbers have their bases. Decimal has base 10, which means it includes number from 0 to 9. Binary has base 2, it includes number only 0 and 1. Octal has a base 8, which means it includes number from 0 to 7, and hexadecimal has a base 16, which means it includes number from 0 till 15, but numbers from 10 to 15 are represented by alphabets A, B, C, D, E, F in place of 10, 11, 12, 13, 14, and 15. Now, in this lecture, we will learn about the conversion. So first, we will learn the conversion of decimal numbers into octal numbers. Now, let's learn this conversion through this video.
For decimal to octal conversion, we have to divide integer part by 8 and multiply fractional part by 8. We are multiplying and dividing by 8 because base in case of octal number system is 8. The base or radix R is equal to 8 in case of octal number system. So we have to divide the integer part by 8 and multiply the fractional part by 8. I will explain this conversion by the help of 2 examples. In the first example, I will not include the fractional part. We will include fractional part in second example. So let's start with example number 1. The decimal number is 112. This is in decimal, and we want octal equivalent of 112. We have to divide 112 by 8 because we have to divide the integer part by 8, and when you divide 112 by 8, the quotient is 14 and the remainder is 0. We will again divide 14 by 8 and we will have quotient as 1 and remainder is 6. 1 divided by 8, quotient is 0 and remainder is 1, and we will stop here. And this 1 here is MSB and this 0 here is LSB. So the number is 160. We have to start from bottom and we have to go up, right? So 160 is the octal number which represents 112 in decimal. 160. This is the answer.
Now move towards the next conversion, that is decimal numbers into hexadecimal numbers. Here is again a video for this conversion. Watch the video carefully and comprehend it completely.
The next conversion is decimal to hexadecimal. For decimal to hexadecimal conversion, we have to divide integer part by 16 and we have to multiply fractional part by 16 because 16 is the base in case of hexadecimal number system. The base or radix R in case of hexadecimal number system is 16. Problem number 1. The decimal number is 254. This is in decimal and we want hexadecimal equivalent of this number. So let's start with it. $254 is the decimal number and we have to divide 254 by 16. we have to divide integer part by 16, and when we divide 254 by 16, the quotient is 15 and the remainder is 14, because when you multiply 16 by 15, the result is 240, and when you subtract 240 in 254, you will have 14 as remainder. We will again divide 15 by 16. The quotient is 0 and remainder is 15. Now if you remember the first presentation, we had 16 distinct digits in hexadecimal number system, starting from 0, 9 and 10 is written as A is 10, B is 11, C is 12, D is 13, E is 14 and F is 15. So this 14 we have to write E and this 15 we have to write F. This F is MSB, the most significant bit, and this E is LSB, the least significant bit. The most significant bit is the leftmost bit, so F is the leftmost bit, and the least significant bit is the rightmost bit, so E is the rightmost bit, and this is the hexadecimal equivalent of 254.
Summary. Now let's summarize today's lesson. Each number in number system has their bases. Decimal has base 10, binary has 2, octal has 8, and hexadecimal has base 16. To convert the decimal into octal or hexadecimal, we use repeated division method. For octal, we divide the decimal value by 8, and for hexadecimal, we divide the decimal value by 16. We have to keep dividing the quotient till we get a quotient less than the divisor. We then record the remainders from bottom to top to get the answer. So students, now it's homework time. Learn the basis of number system and do the given assignment. Assignment file is posted separately with your lecture. You can read page number 5 and 6 from your course book for further details and queries. Hope you have found today's lecture informative and easy to understand. Thanks for watching and keep on practicing. Take care, stay safe. Allah Hafiz.